All right, let's see how we would solve this. I want to write it in polar form. So the first thing we're going to do is graph this in the complex plane. So I've got my real axis and my imaginary axis. So this complex number can be thought of as the point in the complex plane with its real coordinate is square root of 3, and its imaginary part here is -1. So if I've got this, -1's about there. Square root of 3 is 1.71 something. So I just renumber these 2, -2. So just doing it freehand, I want to try and make this pretty obvious. So the point square root of 3 comma -1. So square root of 3 would be about there. And there's -1. So that's where the point would be in the complex plane. Okay. So now the next thing I want to do is find r. Because in polar form, you can write this as r times cis of theta, where cis is that shorthand for cosine theta plus I times sine theta. So let's find r. By definition, r is the distance from the origin to our point in the complex plane. So r is going to be that distance, which we saw in our notes here. R is the same as the modulus of z, which is going to be the square root of the real part squared plus the imaginary part squared. And so the imaginary part squared is -1. So we're going to have square root of 3 plus 1, which is square root of 4, which is 2. So the modulus is 2. So I can refine this. I just need to find theta. And to find the rest of this, I'm going to make some more room now. I'm going to draw a right triangle. Because, well, what is theta? This is going to be my theta. And now to find theta, I'm going to draw a right triangle made from this reference angle. So that's our reference angle for theta. If I know the reference angle, then I can get theta, because theta will be a full revolution, which is 2 pi minus your reference angle. So let's do that. Let me draw this big triangle, a right triangle. So I'm going to create this right triangle here. And now I'm going to make it bigger. Okay, so work with that out here. Okay, so I know that this side has length square root of 3. This is r, which we found was 2. And then this leg here has length 1. And this is my reference angle. Okay, so if I label these as a right triangle, then we have opposite, hypotenuse, and adjacent. I can take the sine of my reference angle, and it's going to be opposite over hypotenuse. And we should know from our common angles Now, I haven't been told whether to put in degrees or radians. The example in the book does it in radians, so I'm going to do in radians. So of our common angles, sine of pi over 6 is equal to 1/2. So my reference angle here is equal to pi over 6. Now that I know my reference angle, if that's pi over 6, then theta is going to be a full revolution, which is 2 pi, minus the reference angle, which is pi over 6. And this is where I need to rewrite 2 pi as 12 pi over 6, so I can put these together. And that's going to give me 12 pi minus pi is 11 pi. So I finally finished now. So in polar form, it's my complex number z is equal to 2 times cis of 11 pi over 6. And in the book, you'll see that they write the answer as in longhand. So cosine of 11 pi over 6 plus I times sine of 11 pi over 6. But cis, C-I-S, is the shorthand for that. Okay, so that completes everything here, and that ends the video.